If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Please share it with all others who might benefit. Let's get started. So, progressing step by step in our ensembling journey, we have now come to the sequential models, and here the technique that we are going to talk about is known as boosting. If you've ever participated in a data science competition, it's a technique that you can't afford to avoid. So let's understand at a very high level, what is boosting? How is it different from the other techniques that we have talked about so far? First of all, boosting uses the same type of base model. We are doing ensembling, so we are of course dealing with multiple models. Now the choices are the models same or different? Now in this case, all the underlying models will be of the same type. Well, these models learn sequentially. At each subsequent step, they focus more on correcting the errors compared to the previous models. So if we were to represent it in a picture form, it would look something like this. Let's say you start with a base model, and you would of course not do very great to begin with a simple model, but you note down where you're not doing good, and you try to improve on those in the subsequent iterations. These models do not have to look identical, they have to be of the same type. That's important. So it's just like we appear for a test, and we could be asked questions from multiple topics. But let's say on a few topics, we're not doing that great. When we appear for the test first, we get to know which are the topics where we did not do great. In the subsequent tests, we continue to prepare better on those topics and continue to improve ourselves. That's the very same analogy that applies to boosting techniques. These models are weak models to begin with, which means they're not very complex models. They're simple models. Often you would see just a depth of 1 in a tree or some other simple model. It doesn't have to be a tree only. But you would see that these many weak learners put together come up with a very reliable and strong outcome. That's the beauty of boosting. Now, in boosting, we have two broad categories. First is adaptive boosting, and the second is gradient boosting. Let's understand each of these one by one. Adaptive boosting essentially trains a sequence of weak learners adjusting the weights of misclassified instances to focus on difficult samples. So it's like you get a feedback that these are the two topics where you're not doing great. You start allocating more focus on those topics. That's what adaptive boosting does. You adapt to the feedback that you receive, and you continue to improve yourself over the iterations. What is gradient boosting? Gradient boosting fits a sequence of weak learners to the residuals or errors, aiming to reduce the errors made by the previous model. So if you see, it may be a little confusing as to how is this different from adaptive boosting. Let's understand this quickly. So adaptive boosting is trying to address a problem at a classification level. If the actual label was given to you as 1, but you predicted 0, that's a problem. Or if the actual label was 0 and you predicted a 1, that's a problem. So you're looking at the end result level and you're trying to say that we have gone wrong and we want to improvise this. Gradient boosting, on the other hand, would focus on reducing the residual, which is the difference between the actual and predicted value. So let's say your actual label was 1, but you predicted the probability is 0.6. So the difference between 1 and 0.6, which will be, let's say, 0.4, that's what gradient boosting is focusing on reducing. Or if, let's say, the class was 0 and you predicted a 0.2, again, could you be more close to 0? That's what gradient boosting is going to focus on. A variant of gradient boosting, which is very popular for its performance and quite popular in competitions, is known as the extreme gradient boosting. This is just a short introduction. You can say barely scratching the surface. If you want to learn a little better about adaptive boosting and gradient boosting, I'll provide you a link in the description to detailed videos where we have covered all the math behind these as well. And that's not something which you will very commonly find in just about any other tutorial. So if you're serious about learning this, you may refer to those videos and get better understanding.